Okay. All right. All right. Okay. So now we're officially ready to start. Welcome everyone to the August 20th, 2022 Seattle Robotics Society monthly meeting. As I said before, it's truly an honor to have all of you here and to be your guest host today. I think this will be a fun and engaging meeting. Okay, so here is kind of our itinerary, our overall general agenda for the way that we run the meetings. We will have announcements as far as club business and overall event notes that are coming. We will talk about today's and future presentations that are on the docket. We will talk about our Robothon updates, and we will talk about the SRS robot kits, the club robot building kits, and we will have a breakout session, so to speak, for around the room to share your information on projects, ask questions, etc. And then we will take a short break, and then we will start the presentation for our feature presenter, and then we will wrap up the meeting. So that's going to be the overall flow for today. And our meetings, as I said before, are recorded and posted on our YouTube channel, the club's YouTube channel. Okay, and as I said before, please mute unless you are actively sharing and speaking. And please go ahead and use the chat feature of Zoom to ask questions, make comments, and include any relevant links for information that you wish to share. And here is on the bottom part of this slide, this is the general for Steve, who is our regular meeting organizer. That is the general email address, free Gmail address that you can readily contact him at for questions, to offer up presentation ideas, or to volunteer either yourself or someone else for a presentation at a future time that you want to have scheduled. All right, so some club business. Right now, the club is still exclusively meeting online like this, but at some point in the future, the club will be showcasing for our regular monthlies using a hybrid format, where we will be meeting at the newly acquired First WA meeting location. And we have the address here for that new facility. The First WA environment, from what I understand, the latest updates is that they are still working to get everything set up on their side. We cannot possibly, within a few months yet, be able to use the facility. And we will let you know whenever the meetings go to the hybrid format. And I already mentioned this about the hybrid format. And what's going to have to be required to allow for hybrid is that we have multiple volunteers to help run the equipment that will allow this Zoom connection. So if anyone is interested in helping with that, again, please contact Steve at the email address below. That would be fantastic to have those kind of logistics set up ahead of time. All right, so here is a listing that Steve provided for upcoming of interest events. And again, these links and more details for other types of interest events are posted on seattlerobotics.org. Steve has a special section on the site for this type of information. All right. I am Donna. I am part of the Robothon Planning Committee. And so I have some updates regarding in-person and virtual Robothon contests, exhibition type events. So right now, unless things go south with COVID, we are hoping to either fully in person or a hybrid type format Robothon event with our with contests being available to watch and enter and compete in come the fall time of next calendar year, so fall of 2023. That's what we are hoping at this point. The club does have a website. That's the second of two club websites I'd mentioned before, called robothon.org. That is where we have everything related to in-person and virtual Robothon events and showcases for our robotics events. And so that's robothon.org. So everything is updated on that site. And also coming this next Saturday, August the 27th, starting at noon Pacific time, we will be having our virtual Robothon exhibition showcase, sharing of projects. It's a education sharing event, though I am the primary organizer for the event, and Lloyd Moore will be the MC for that event. And again, all the relevant details are listed on robothon.org for that. And at this point, I'd like to encourage all of you to come as an attendee for that event. Again, it's going to start at noon instead of 10 a.m. on that day. So please put that into your schedule for the day. Okay, so here is some other events that are coming in this calendar year. The Snowco Makerspace, which is organized in Everett, will be hosting their Pop Can Challenge contest. And that will be on October the 1st, starting at 10 a.m. And I know that Chaz is one of the organizers for that event. Chaz, I know that you're online this morning. Did you have any comments for the audience today on this challenge that's coming up?
Yeah, thanks. It's free to attend, so don't worry about having to bring money or anything. And it is the Seattle Robotics Society Pop Can Challenge. We're just hosting it so that we could, kind of need to do it in person to have the challenge, at least because the arena is a little on the large side. We kind of built our own arena because we don't, I'm sure the official arena is all packed away somewhere right now, but it is missing the if you go on to the Robothon webpage and look at the design inside the SRS PopCan Challenge page itself, all the places your robot shouldn't be, which is the far side of the rooms in the mock living room and the mock kitchen, are we don't have the space to build out those pieces. So it's basically about 2/3 of the living room, the hallway, and then 2/3 of the kitchen. So if you do have a robot and you plan on bringing it, you might have to make some tweaks to your robot for that. If you use some sort of mapping and you're expecting some certain walls to be where they're at, they're going to be slightly different. But
Okay.
yeah, we'll be there.
Okay, terrific. Thank you, Chaz. Also,
No,
that's going to be a hybrid event, right? And of which the meetup information is, or for the Zoom and all that is provided. So, okay, great.
Absolutely.
Thank you, Chaz. Appreciate the information. Okay, and then as I mentioned before, the club is always looking for presenters. We have a featured presenter today, and I will be introducing her soon and providing more information. But Steve, again, as the meetings organizer and regular host, he's always looking for presenters, and either international presenters, worldwide pool basically, or just either local or USA based presenters, anything that is specific to our technology interests, especially if it has something to do about robotics, either directly building a robot, some kind of topic on that, or a subsystem of some type that goes into building a robot, either hardware, software, you name it. As you all know, our robotics hobby is so far and wide as far as the types of skills and the pieces that ultimately need to be decided on, chosen, etc., that actually go into robots. So it's a huge area of types of topics and also their respective presenters. So if you yourself are interested in being a presenter at some future date, or you know of someone, please go ahead and email Steve, again, at the email address provided at the bottom of this slide, and provide that in kind of information to Steve, because like I say, he's always looking to build the pool of presenters for these monthly meetings. And here is the current docket of presenters. Today, for the August 20th meeting, we'll be having Cecilia. She will be talking about a topic of combining art and robotics. So that should be fun and interesting and educational. And then, so September through December, we have a chosen presenter per month, but starting January of 2023, currently we are open. So again, please consider presenting or suggesting a presenter. All right, so we will be having as I said, Cecilia is our guest featured presenter today, and soon she will be on stage to share her great topic, and we look forward to that. And at the end of the meeting today, after Cecilia's presentation, we have an open mic, an open sharing session where this Zoom meeting stays open for as long as people want to stay. And we have a virtual robotics discussion that ensues after the meeting is concluded. That the meeting is not recorded. In fact, I stopped the meeting recording at the end of the formal meeting. And so, but you are free to stay on the Zoom meeting and share and discuss your ideas and questions. All right, so at this point, we are at the point in the meeting where we have our show and tell. It's kind of around the room or around the web, as Steve puts it, if you have something to share. And we have a good half an hour for this section. And so I encourage all of you to come online and share your projects, ask questions, and we can have a general robotics discussion. So I will let everyone go ahead, and I will go ahead and stop sharing at this point. And I will open the floor to whoever wants to go first.
This is Dick.
Yes, hello, Dick.
I'll give a try at showing a little bit. Not sure how to do this, but so I have to share screen, correct?
Yes, yeah, you click on the green icon itself for share screen. And
Okay,
then
there we go. See what happens. Let's see. Yeah, we'll go for this one first. Okay, this is just about my recent activity. By recent, I mean since COVID started. So I worked on a few different things. One is a communication protocol, text-based, so you can actually, it's human readable. I was working on a robot for RoboMagellan before COVID started, and I just suspended that, except I did spend a bunch of time early in, the first half of 2020 cleaning up the code I was doing for the robot. So I got it all set up, hopefully so I can understand it when I look at it again. And then I set it aside to work on some other things. One of those was I wanted to be able to go outside in winter. And I have a problem. My nose has a kind of a chronic problem. The cold air aggravates it. So I was going to make a mask heater that I don't have a picture of it handy here, but it's there's a heating pad from SparkFun that runs on 5 volts. So using that plus a temperature sensor and a processor to manage the heating on and off cycle based on what the actual temperature is and the desired setting. It's pretty much working, but it needs to be shrunk down so it's portable. So that's kind of work that still needs to be done, hopefully before winter starts. And to kind of go along with that, I wanted a portable mini monitor that I could hook on to things like a robot or my mask heater for setting parameters or requesting reporting of what's going on inside, whatever it is, the robot or the mask heater. Another thing I worked on was this was a pretty simple project. It's just like a temperature sensor for infrared, and that was working just fine. Most recently, I've been working on ESP8266 Wi-Fi, and I'll touch on that a little bit later. And the last thing on the list there is the Pololu 3 Pi Plus. It's their old 3 Pi robot had an LCD screen. And I think it was about last summer that they switched to an OLED screen. So I got one of those robots, and so far I've only run the sample program. But at the time I purchased that, I also purchased 2 of those OLED screens from Pololu. they have them separate. So you can purchase them separate, and they're about $11 or something like that. And it's 128 wide, 64 lines, pixels. The next screen here is the same list, but a little different information, basically about what processor was used in each project. You see TT 3.2 there in a few places. I like Teensy. It has extra serial ports and it's got a lot of memory and and my favorite processor. And I've used several to that. I used for another project because it had a huge amount of memory. Okay, for the mask heater, I used a Pololu A-Star, what they call A-Star. It's a 32U4, I think it's another Atmel processor, but it's got kind of some extra stuff. The mini monitor, that's using TT 3.2 temperature sensor. I decided to use another Pololu A-Star, but this is a 328 PB. It's sort of it's a kind of an upgrade of the processor that's on the typical Arduino Uno. It has an extra serial port and it's got some extra stuff too. So in a way it's better, but it's packaged not an Arduino shape, so you can't really plug the plug boards into it. But I wanted to give it a try because it was a very small package and didn't take up too much space. As far as the ESP Wi-Fi, I decided to go with the Adafruit breakout. So it's the ESP8266 or a version of that. Put on a breakout board because that Wi-Fi module, you just can't use it alone. You have to add some things to it, like some buttons and and some pull-up resistors, just a few things, but it was handy just to buy it from Adafruit already worked out. Then the 3Pi robot, I hope to explore that pretty soon. Okay, moving on to the next screen here. The communication protocol, I just wanted to bring up because I found it to be very useful. I'm pretty happy with it. And it's kind of a minimal thing, so it can be put on a processor that doesn't have a whole lot of memory. Numeric value based, and there's kind of a hack where you can actually pass text with it too by packaging it into numbers. And humans can type and read the protocol, so it's handy for testing. And there is a lot of flexibility in the usage of it. The simplest is kind of a numeric argument list. You're going to say you're going to call a function. You have to pass arguments to it. So the way this at the bottom, you can see where it has shows the format of the arg list. It starts with a pound sign, then you have a string of numbers separated by commas. And then there's an end character. The simplest format of this is you just put in some numbers and a character at the end. You know, you can use alphabetic characters, any character that's not a numeric character or anything that's in the argument list. So it rules out using numbers, commas, but it's very simple to use. The routing example there, the first three arguments. First is the destination of where you want your message to go, and identify yourself as the source. So these are just numbers that code who's who in the communication system. Then the third thing there is shown as the command. I'll get to that next. Then there's just kind of an end character, which I just, instead of having the command at the end, in the simplest form, that's the way it works. This, I just use a certain end character, an exclamation mark. It's just a trigger to start things going. So moving on to the next. So the mini monitor, there's a menu system. We'll take a look at that. I've got a couple of photos. You can set operation parameters to send to whatever you're connected to. In the case of the mask heater, I want to send a set point or a temperature to be maintained. You can request status reporting, for example, and get, say, the heater, the mask heater, to report back temperature, and you can specify at what rate to report, basically in seconds. Display was black and white, but it is that graphic OLED. And I'm finding that works pretty good. It's kind of tiny though, so you have to have, for me, in order to read it, I wear bifocals and I have to look through the bottom part to be able to read it, or put a magnifying glass on top of it. Now, I have got a photo where I've done just that, so you can see it. I may add data logging to this, because I did data logging with that teensy 3.6 previous project. I might just switch over to that, because it's already got the logging in it, or borrow it from there. Since it's teensy 3.2, which has 3 serial ports, 2 of them are available and they're brought out of the monitor for connecting to. The third serial port is tied up with running the graphic OLED. Okay, we're getting close to the end. I don't know if anybody's looked at this ESP stuff. YIDI 266 is what came out first, and the more recent one, which is more expensive, is ESP32. I may get into using that if I need extra horsepower. But right now, the 8266 seems to be fine for what I'm doing. Depending on what programming you load into it, it can either act as a workstation and connect to a LAN access point. That's like your typical Wi-Fi you have in your home. So your laptop is a work, and from there it gets to the internet. But this, the programming I loaded into this will also provide a soft access point. So if there's no local network available, so you got a robot out in the field somewhere, this thing can provide the access point, allowing a station to connect. You know, a station might be your cell phone. And that scene, and your cell phone would have access to your robot. So the robot would be connected to the ESP, and the cell phone would connect to that. Let's see. Yeah, so there's a serial port on this thing, which is used for programming. And then for testing, while you've got it in that Arduino IDE, you can use a serial monitor. But the other way to use it is connected to a robot or whatever. So you see, ESP can serve up a web page or multiple web pages. Right now, I've only got one. But you can connect to it with either the two scenarios that are listed at the top, through the LAN or the soft AP. Now I put kind of besides the basic software that you can just load into this thing, you can also modify that and add your own stuff to it. So I put a little menu in there for configuration and debugging. Right now, it doesn't do a whole lot, but you can connect to that either way. So this is just about the communication protocol. It's got a menu in your programming that you access usually with a serial monitor. You can set up the menu to be based on a menu selection by maybe any character you use. This example here, the pound sign is the beginning of the argument list. Here we just have one argument. There's a comma to end the argument, and then there's a D, which your menu handling system would recognize to mean enable a debug output. So the 1 would be like true to enable it, and 0 would be disable it. So it's just the simplest use of this protocol. So I'm actually using it so you can type in some of this protocol stuff to work the OLED screen. So if I hook this up to say if I hook up the monitor to the screen, you can send commands to it to either put numbers or text or graphic drawing on the display. So here are some examples. So in this case, the first 3 arguments, first is the destination, and 5 in my system is the display. And 6 is, what is 6? Well, I don't remember that. But then the third thing here is the command. We want to draw a line. And then there's an argument list. The rest of the arguments in the list are the parameters for drawing the line. So there's the starting point and the end point, X and Y. Then the exclamation mark is just the trigger to get it moving on that command. So that's like a single, just a single command. Or I actually call it action. The action is to draw the line. But if the action argument is 0, that indicates that you can string together a whole bunch of actions that don't require more than one argument. Either be 0 or 1. And after the decimal point, in this case, the fractional part indicates the actual action to be taken. So here we want to clear the screen, and we want actually the clear is to clear the buffer in the display, and then from that you update the display. So it's a kind of a 2-command thing to make that happen. 03 is set font, and here we want font number 1. And this is to get things moving. Okay, here's an example, set cursor. So this is like the X position or the horizontal. And these are pixels in pixel space. And this is the vertical or the row. We're going to go over to the right 10 and down 8. And we want to set the cursor there. So that's kind of one action there. And then the next action would be to draw some text. And this is the way you get text in this protocol. I didn't want to start handling strings because that would complicate things and make it too big to fit on small processors. But you can get 3 characters per argument here. And then O8 is to print text. And so these numbers over here represent STA. So that's the protocol. And the other thing I want to show is, let's see, I need to figure out how to change new share. Oh, this is what I want. Okay, this is through a magnifying glass. It's the monitor screen. And what I use it for is the USB 8266 will make a connection to your LAN, but you won't know what the IP address of that connection is. So if you want to access the web page on this, you really need to know what that IP address is. So I connect the monitor to the ESP 8266 second serial port, which spits out graphic commands to tell you what IP address to use. It's kind of a weakness in this ESP system, Wi-Fi system, is it kind of leaves you guessing as to what IP address to use. Typically what it does is if you're hooked up to the serial monitor, when you run the ESP, it will spit this information out to the serial monitor. But if I'm going to have this hooked up to a robot, that's not going to help me a whole lot. So using the second serial port, which by the way on this ESP 266 is only available for the transmit, the output, because the receiving, what would be the receiving pin for that second serial port is used to control the radio of the Wi-Fi. So you've got half of the serial port. But anyway, it's useful the way I've used it here. All right. So my pointer here is this is the ESP 8266 on the Adafruit breakout board. There's an LED hooked up to it, and I added a push button. Probably don't want to go into this too much, but pushing a button will cause the LED to go from red to green and green to red. It's like an on-off type thing. But when you connect to the ESP 8266 from a web browser, you can do the same thing, turn the LED on and off. This is just a battery up here. I got this one, or both of these, just one over here. But I got those from SparkFun, and I've been really happy with those. They're LiPo. So here's the monitor. I would like to give a live demo of this, but I haven't been able to get a reliable picture on to work with, to give you an idea of the user interface on this. Is the screen, and then there's this what looks like a button, or it looks like a volume control on a stereo or something, but it's actually an encoder. It's a quadrature encoder. So it's hooked up so that it can read the setting, or it can read the encoder, and it keeps track of how much it's rotated. So you can use that information, or what a menu. And we'll see that in a minute. The other thing about this knob here is it's also a push button. So that's the user interface, a twisty knob and a push button. Okay, next. Let's see if I can rotate this. So we've got the knob here. So there's also an LED associated with it. It's actually a RGB. And now on the screen, it's showing the menu that I've got in there. And by twisting the knob here, you can move this little cursor, this asterisk. You can move it up and down to select a line in the menu. Down here is a line for setting the temperature, say on that mask heater I was talking about earlier. Right now, the default temperature is 70 degrees. Here we go again. So you see the cursors move down here. The LED went from red to green. That was caused by pushing in on the button for a short time, about a second. And it switches into edit mode. So now when this is showing green down here, when you twist the edit button, twist the button, it will increment or decrement the number here. So it just edits this number right in place. And then the next step after you've got the temperature setting that you want, you push the button again. This time you have to hold it down for a long time, like 3 seconds. And the long hold down causes it to accept the setting, the new setting that you've picked. And the next step, I don't have any more pictures, but the next step would be to go up here to where it says send changes and move the cursor up there, click the button, and it would send the temperature setting to the heater. And not only that, but it would respond back with an acknowledgement that it received it. That's kind of the way that works. So there's more settings further down in the menu for setting the reporting request. You indicate, how frequently you want the temperature to be reported back to the screen here. Of course, once that's done, you have to close the menu here so it can display the temperature coming back. And I don't have any pictures of that. So that's just, it's only 4 pictures. So I think I'm done. Anybody got any questions, or think this is kind of a dumb idea, but
I have one, Dick. First
Okay.
off, thank you for sharing your great information on the various status on the projects that you're working on. Great job. And I have a question especially related to the communications protocol that you have put together.
Okay.
So have you, or do you plan on posting that code with, you know, information as far as how to use it? What I'm specifically asking is if you have considered posting your, you know, these individual like subsystems that you've developed, like the communication protocol, either on an Instructables project or on a GitHub repository. So that's a question / comment that I have.
Yeah, actually, well, it's quite a while ago. Maybe might have been a year ago when I was. Actually, it was 2 years ago when I started working on that protocol, and I originally did it for the robot, the Magellan robot. It's got a bunch of that protocol in it for, you know, sending commands for it to move and stuff like that. And it might have been a year ago that I actually put some information about this protocol. I just on the SRS, well, our what do you call it? The you know, where we can send messages, right? You know what I mean?
Not exactly, no, but
Well, we've got SRS has it's at io.org or.
are you talking about that section of the website that Steve has to like, well, it's kind of an updates section as far as project status and kind of / blog content?
Well,
For-
it's not the website. It's like the I'm not coming up with the right terminology for it. It's kind of the old-fashioned thing where you post.
Oh, you mean the the encoder?
IRC channel?
No. Just the you know, you post a message and it goes out to everybody that's.
Oh, you mean the email list service?
Right. Yeah, that's it.
Oh, okay.
So
well-
I did put some information about this protocol there, but yeah, I want to do that again. Either put it there, or I even thought about making an article for the encoder.
Well, the encoder is no longer a viable option. All that has been shut down. It's just available now in legacy format. So
Oh,
that part isn't available anymore. Well, what I would suggest is creating a GitHub repository for it.
Yeah.
So,
So
okay.
I've used GitHub a little bit, so yeah, I can do that, or I will do that. Put it that way.
Okay. Does anybody else have any questions or comments for Dick on his project status?
I just wanted to commend him for that menu structure. I always enjoy adding that type of user interface to my projects. I know that it can be very helpful in interacting with your project to have a well thought out menu structure.
Yeah, I could put that somewhere too. It's kind of, well, there's a lot of code involved to make it work. And right now it's hardwired to one specific application, but I could eventually post that too. It just needs a lot of cleanup first.
Okay. Good job again, Dick. Thank you for that.
Okay.
So with that, let's see. So we've basically run out of time for the around the web section right now. But at the end of the meeting, once that the meeting is officially over after our featured presenter, we can open the floor again for further discussions similar to this. So you have not lost out on your chance today if you wanted to ask questions or share information on your projects. But it just, it won't be officially recorded. Okay, so with that, I'd like to take like a 5-minute break, and we will come back at 11:09 according to my clock. And so and then at that time we will announce our featured presenter for the day and have our featured presentation. So with that, we will rejoin in 5 minutes. Okay, everyone, it's time to get the meeting going again. And with that, I would love to welcome our featured presenter today, who will be talking about art and robotics, and that will be Cecilia. Cecilia, I would love to have you open the floor at this point. You have full share screen access, and so please take it away.
Okay, awesome. Thank you. Good morning, everyone, and well, or afternoon, wherever you are. So yeah, let me share my screen.
Just to let you know, Cecilia, your audio is just a little bit low. So if you can.
Hold on 1 second. Does that sound better? Okay, does that sound better? Yeah, okay. So anyway, my name is Cecilia Olivera-Hillway. Just a quick note about my background. I grew up in Mexico City, in Mexico, and my parents were both computer programmers. But I was the youngest out of 5, so by the time I came along, they were a little tired, so they only did like a half-hearted attempt to get me to coding. But I was really not into it. It was back when BASIC was the language taught in schools. And I just, it was too abstract for me. It was just too much work for just like in my feeling, like not a lot of results, right? So instead, I liked doing art on the computer, and I decided to go into graphic design as a career. So I became a graphic designer, and but as I was studying graphic design, I discovered I liked illustration much better. So my emphasis has turned into illustration. But I came to the US because of my husband. He's from here, and at the beginning of me being here, I decided to take a part-time job at a school. I was a teacher assistant, and then I moved to IT. And while I was in IT, I discovered Scratch. Now, Scratch was a very recent thing, and the school was not teaching it. But I thought, like, wow, if I had this when I was little, I would have loved coding so much more, just because it's so playful, so visual, so fast. What I ended up doing was more combining, art. Like I wanted to have my drawings doing things, right? So that's what I went for. So I just combined like animation and coding. So it was really just silly things, but I thought, oh, the kids might really enjoy this. So I actually started teaching after school classes. I taught myself Scratch just so I could teach, the students Scratch, because I thought it was such a great opportunity, and I did seem to enjoy it. Then I moved to Los Angeles, and I ended up with working for a great person, Adrian Caulfield, who was really trying to turn the computer lab into a makerspace. So together we looked at different things, and that's when I discovered the Hummingbird. This is the Hummingbird Duo, which actually combined Scratch with robotics to make physical computing. And for me, it was like the perfect marriage, because you had easy coding, easy, fast coding, and I'm working with elementary school children, right? So this was great. The Hummingbird would be during this era, it was coded with Scratch. So it was a great melding of, they're learning Scratch, they're also doing physical computing. So this is one of the samples I made for that. So he has a sound sensor. In the back, he has a light sensor. Just so you can see in the back, I have the hummingbird, and it's just using, 3 servos. The connections are pretty easy. We have the sound sensor and the light sensor is right there. This was one of the first generations of that board. So, and you can see in the background, I have Scratch playing in the background. This is how I coded it. So, pretty simple coding, but it worked for me. It worked perfectly because I just want, I don't want to get bogged down by the coding. I just want to keep like be playful, get the most out of my very small amount of time I get to making. It's just works for me using block coding, especially since I work with elementary school children. So it's one of those they call it the low floor, high ceiling. So the entry level is pretty easy to get into, but if you get into it, you can really do a lot of things with it. So this little guy, we were doing toy take apart activities where you had, the electronic toys, and so they would see the components. But I said, well, how about reusing the components of the toy take apart? So this was just a silly, they had a little Snoopy that had been, grabbed. So I just made it into a little rover. And I think I show it here. I'm using a little remote made. So at this point, it's microbit. So microbits for me were a game changer because they're it's no longer Scratch, it's make code, but it's the same basic principle. And since microbit is pushed by the BBC in the UK for teaching students, they have a lot of interest in making it as widely available, and as it has a lot of companies investing into making add-ons and expansion boards. So for me, the microbit has been a perfect tool because I can, like I said, combining my poor coding skills, which are block coding, with art, and because it's so easy to combine both. Let's see. So as I got making samples for students, I decided that it would be a great idea to just keep making my own thing. So I started going to maker fairs. This is a mini maker fair where I was demoing a little motorcycle Snoopy that I made, the motorcycle, and combining laser cutting and 3D printing and stuff. But anyway, so I got really into it. So even if students, I don't know, at that point, I don't know how students were reacting because I was mainly helping at a makerspace. So it was an interesting thing for me because I was making my own projects and the kids were doing their own projects. I would help them out, and I would also show them what could also be done with it. So then my husband and I decided to move to Washington, to the Olympic Peninsula, because we wanted to be around nature, and he's actually from Washington. So Washington State, I should clarify. So we moved up here, and I knew that the opportunities would be a little more limited because we're in a very tiny town, and you know, I started focusing more on my illustration work, but I decided to take my robotics work a little step forward. So I was combining illustration with watercolors and with robotics. So this is a Skeksis from the Dark Crystal, specifically from the series from Netflix. Very good, I recommend it. So, this is, combining watercolor painting with robotics. So taking it a step forward. This was just one project that I made, and I actually had that as an instructable, and I wanna I think honorable mention. I don't remember at this point, but it was about making things with cardboard, which is what I use. I mainly use cardboard and combining with watercolor painting. So so then 2020 happened, and so I had been working at the library, the local library, and suddenly I couldn't go to the library. So I got really, really into making. I got, my illustration work is, a big part of what I do, but I'm mainly focusing right now in this talk to robotics. So as in robotics, I started posting a lot of work on Twitter because I was no longer working directly with schools, but I still use a lot of educational technology components. So I would showcase what I did. I posted it on Twitter, and I started getting a big response, especially from teachers and from the companies that actually make this kind of boards. This is again all with microbit. This is an expansion boards. So this was me going a little overboard. Again, watercolor painting with electronics combined. So I decided like it would be a great lesson for students to have like a, talking about biomes or something, and each student builds a different robot. This video doesn't show it, but I have another version where I have kind of like a museum controller. So you tap on each button and the robot does its thing while it's getting the spiel about what the animal does. Like this is the Harris hog, and the Harris hog does this and that. So people responded very well to that. So I kept making things, and by making and posting on Twitter, I was invited to teach at Bainbridge Island barn. I don't know if anybody knows that, but it's a makerspace. So I thought again, what I'm using is a microbit, but specifically with the hummingbird bit is called. It's the new generation of the board where that started it all for me. So these are student projects, so you can see, how that was loud. So students are combining crafts and art to make their own robots. So students who would normally not be interested in doing anything like this get really invested. Like this kid took so long to make that robot because he wanted the painting perfect. But they really get into their project, and since the coding is so simple, they can invest a lot of time in how their project is going to look like. So and it's a big part of what my philosophy is to let the students really decide what they want to do. So they get the complete choice of the decisions, like from what animal, what is it going to do, everything they get to decide, and I'm there to enable them to be able to do what they want. Also been teaching Make Code Arcade, which is kind of like a retro gaming thing that is also block coding. Now, the advantage of using make code is that it does have an option once the students are ready for it to change into doing written code instead of block coding. But that's, and some kids are really into coding, and that's fine. I can assist them with the coding, but mainly, like I said, what speaks to my heart is the visuals and the art. So, and that, by being so passionate about that, I attract certain students who would normally not want to, even try robotics, because robotics, the default assumption, I guess, the robotics is just too dry, which it's not. There's so many interesting things. I mean, look at what Boston Dynamics does. It's just, it's so amazing. But by making it a little friendlier for them, some students can do it, who would otherwise not be inclined to do it. So this one, I was contacted through Twitter by a company in the UK that was building a sensor kit to sense air quality, and they reached out to different makers to make like a visually compelling project which would show air quality. So in my case, I decided to go for a bear that shows the air quality index. So he changes expression depending on how the air quality is. So he goes through the whole thing, and if it's like, hazardous, he freaks out. This is, of course, that was the demo version. It would be, a more gentle transition. So it has a button, a toggle switch on the top, where it's like local. So it just uses the sensors that they built, and also a regional that uses an API. So in my case, since I'm in the US and I'm in the West Coast, the forest fires are a big thing. So I have the API to fine tune to the local forecast of my area. So I can put flip the toggle switch to regional, and it'll show me the forecast of how the air quality will be. I think the forecast is like 1 or 2 days beforehand. I'm honestly not sure, but anyway, so I was contacted. I made this project, and I actually liked it so much that I'm currently working on 6 other bears like this, because I want them in schools in Malta, in Europe. So that worked out great. This is one of my most recent ones. I did not make the artwork for this, but I was approached, like they had this poster and they wanted it moving. So this was, just like making it into some like the physical animation with the elements of the poster. This was one of the tests. I unfortunately did not take photos or video of the actual site. So this was one of the tests. So with that, I think for me it has been very very important to see the reaction from teachers, especially because, like I said, since I work with educational technology, teachers really respond to what I make. Because then they can implement it with students. And well, I have students too, but posting it on Twitter and all that makes it, let me change the camera. Oh, that's not what I wanted. Did that work? There we go. Okay. So, like I said, so companies, the educational technology companies approach me, and like this one it's a Pinbox 3000. the company makes cardboard machines, well, pinball machines, sorry. So they approached me, and I combine my illustration work with the electronics. And this little dragon that I'm gonna show you here. Hold on, sorry. So this guy, I made also I made an instructable with him, but so I have the remote control. Am I grabbing it? Hold on, you always grab it upside down. There we go. Okay, so I have a sound sensor that is picking my voice, so the sound level of my voice, and it's you know, lip syncing in a way to what I say. So you know, this it started as a different project. It wasn't supposed to be lip syncing, but since I already had the mouth made, I decided to turn it into a lip syncing robot, which I got a very good response for this. So, you know, that was exciting. So again, you have the neck, the moves, and I have the controller upside down, I think. Anyway, so that's one of the most recent ones. And this little avatar is also, I also made a instructable for it, and it was a microbit specific instructable contest. So again, it's lip syncing, and I can make the head move and the arm move. So the idea was to create a character that I could use for videos, so I didn't have to appear on the videos myself. So I'm using a little remote control that is talking between the two microbits. So it was a lot of fun. So anyway, like I said, I get approached because of the friendliness of combining art and technology, and teachers really respond to it. Oh, hold on, I accidentally. There we go. Okay, so so that's it. I really stumbled into making this career because I obviously don't have any engineering background. So anyway, I don't know if anybody has any questions.
I have a question. Your build, let's see, it was the air quality bear.
Mhm.
I only saw the mouth change once, and I would like to see that again. Are you reversing a piece of cardboard in order to get the two faces?
Let me share that again so you can see them. Okay, so have this guy. Let me pause it. So this is all laser cut, and it has the one mouth, so it's going through the thing, and then it flips.
Right.
Like a 180 turn, so the mouthpiece is behind it, so like it changed the expression.
So there's
originally when sorry, when I was originally making this, he flipped into having a mask, but I'm like, no, I like the expressions better.
so so that you have a hole in your plate
Mhm.
there that is the same shape, and then that piece rotates in the hole.
Yeah, I don't have it physically with me, but I have the prototype, so I can show you that.
So so the axle then goes right through that piece of cardboard, or you said is laser cut.
So this is a prototype, so it's not exactly, but
Yeah, it just
so
rotates. So it's quite thick. I see.
yeah, so it's just thick enough to have the pivot point be you know the thickness of the servo, so it ends up flush with the cardboard.
Right. Well, it was amazing the expression you can get from that.
Yeah, and it's so quick that it really, people can't tell that there's like a big hole, and
Right.
you know, that's, so this was the prototype. So that's one thing, I always make my own, like, you know, cardboard prototypes first, and especially with this one, because I ended up laser cutting everything. So yeah,
Well, it's all very cool.
thank you. Let's see, and somebody was asking about the steering wheel of, oh, I can actually show you that one. Okay, so this guy, when he turns the steering wheel, it's not connected to anything. He does have a caster down there. So the steering wheel just has a, I don't know if I can show you, it has a wire. So the wire pulls on the servo pulls the wire, and it just makes it look like the Snoopy is turning. So it's just, you know, everything is controlled just with the speed of the motors with a remote control. So it looks like he's steering, but it's just, and he has a, so inside him, I have a coat hanger. So so the servo, when it turns, it forces him to turn. So he looks like he's looking around. So that's this one. Oh, sorry, like my throat got really dry. And yes, it is an artistic effect. Any other questions?
Just wanted to also say how cool I think it is that you're doing this. I have wanted to do this sort of thing for a long time, and I actually built a platform for the ESP8266, which one of our members was talking about before, where you would connect with your cell phone and then it serves a web page. The web page has JavaScript that reads your thumb position so that you can puppet things with it. And then I recently added the ability to record motions and play them back, so that you could actually have the device itself. And then even if the cell phone is disconnected, it can be playing back those things. So it's sort of like an engine for doing this sort of thing. But you're using the microbit, so obviously you're very happy with the microbit. I wouldn't, you know, I wouldn't.
Yeah, but I do use the 8266 for the specifically for the bears to connect to the API, and so I use this one. So it connects
to go get the data. Yeah.
Yeah. So it's the sensor that the company makes. It's actually Raspberry Pi based. So, whoops. So this thing, so it has an array of sensors and it has a Raspberry Pi thing. So the Raspberry Pi serves as my, because the microbit is limited in what it can read, so it can get the protocol for the APIs correctly. So the API actually connects to the Raspberry Pi. The Raspberry Pi then connects to the bear, and that's how you know, the bear has the ESP 866 to read the connection. But
so anyway, I was what I really wanted to say with that was just that building the engine has attracted absolutely zero attention, because I do not have the artistic ability that you have. And you shouldn't, some people may look at something that's cut out of cardboard and painted and just say, oh, that's just cardboard and that's paint, anybody could do that. But trust me, not anybody can do that. So what you're doing is really great. There is one thing I think would be fun for you to look at that I've done, and I've posted a link in the chat. It is a way of putting a smartphone on your robots and then having the brains of the smartphone and the sensors of the smartphone and all the rest of that stuff on the smartphone be available to the robot without
Mhm.
making any electrical connection to your expensive smartphone, which can possibly blow it out. So just something for you to take a look at in the future. And thanks for sharing this. It was really fun. I especially enjoyed the dragon and the other sound reactive stuff. That was really fun.
Thank you. And the sound reactive things, they're very popular. I have several. I have a bear back there that I actually hacked from Target, because Target sells stuffed animal heads for children's decor, because why not? So I turned it into a talking bear. He's quite fun. This guy. I'll show you just because he cracks me up. One of my the one I use a lot for videos because it's just so cute. Oh, hold on. I apparently need both hands to connect things.
That's a really big mouth on that one. I assume you had to move up to a larger servo.
Yeah, it's a standard servo. So
I think it's one thing that people miss about RC servos is that you can get RC servos that can lift a human being off the ground. I mean, you can get really big, strong ones.
Yeah, so this guy, I have him singing. So I post videos on TikTok of him singing. So of course he sings like "Let Me Be Your Teddy Bear" and old-timey Elvis songs, just because my mom was a very big Elvis fan. So he
Now,
just
can
cracks
you
me
put
up.
that on your head, or is there a hole there for your head to go
No,
into his head?
so
Oh, okay.
so
All right. All right. So he hangs on the wall, right?
Yeah, he hangs on the ball. He was like I said, I got him from Target, and they sell him as a wall decor for your children's uh, children's bedroom. Of course, he has the mouth closed, and he's just supposed to hang there with dead eyes. I actually added the white on the eyes because he looked like too dead
Is
to
that?
me.
Am I the only person who thinks that's a little creepy to have a decapitated stuffed teddy bear hanging on your wall? That's
I definitely think so. That's why it amused me to actually make him into a talking bear, because it's just such a weird, random. What were they thinking?
So now hold on now. What you've made here is a zombie, reanimated, dead, decapitated teddy bear. Yeah. I'm not sure that's less creepy, to be honest with you, Celia, but I love it. I think it's great.
So this is the motor that he actually has inside.
Yeah,
so
yeah.
just I had the metallic gears just in case, because it has a stuffed parts in, and I made a 3D printed part that allows him to talk. Okay, but I was worried that it was going to be too much strain on a regular motor.
I just noticed
hard
something
was
else
it?
about that guy, is that I don't hear the servo running. Did you sound isolated, or am I just not picking it up?
Hold on. So I changed to a different microphone because you can't hear the servo. It's just since I'm wearing AirPods, like the earbuds. You couldn't hear.
But still, it's not bad. It's
not bad. The worst one is the little avatar I made, because I have a linear adapter to make the linear movement of the servos, and that one is very noisy.
Yeah.
How hard was it to modify that mouth so that you could move it?
So, let me see. I think I have pictures of this that I could show you. Because I take photos of everything I make. So, and like I said, I post like my successes and my failures online, because teachers also like seeing that. So let me see. Okay, so let me share my screen. Okay, so I don't know if you can see him. So that's what he looked like originally. He had a little tiny mouth. So I opened it up. It had the seam like perfect for me to rip. So I just opened him up, and so let's see. I have videos that I can show you in a second, but this is the actual mouthpiece that he has inside. So it's a 3D printed thing. It just, so you can see there. So this was before I put a little bag on top, so it like the, you know, stuffing. We didn't mess with the motor. So this was one of my first tests. I don't know, can you actually hear the songs playing? This was
I don't hear it now.
No, we couldn't hear it.
okay. So let me see if I can.
There's no small amount of art in your ability to modify that mouth so it still looks good.
Your teddy bear, put a chain around my neck and leave me anywhere. Oh, let me be. Oh, let it be. Oh, teddy bear. Oh, let me be. Oh, let it be your teddy bear. I just wanna be your teddy bear.
And there's the fair use strike against this when it goes up on YouTube, so there'll be no.
Anyway, so I make the TikTok. Well, the TikTok lets you actually use the music, so there's not the problem of that you mentioned for YouTube, but it's lots of fun because it's such a ridiculous concept, like a stuffed animal head that is used for decoration. It's just starting with that just seems so funny to me, so I had to adapt him to stuff.
So
but,
did you animate the mouth by having it listen to the record, or did you have to do it yourself?
So I did both. So in this video that is through TikTok. So TikTok, what it does is like you choose your song and you start recording and you actually hear the song. So you can so the song is playing. I have my headphones on and I'm singing to the sound sensor. So in the end, the bear is not picking up the sound of the music. He's only picking up the sound of my voice, but then TikTok automatically just puts the sound on top. So the one with this one was actually kind of similar, but except I used iMovie instead. It required more editing together, but yeah, I try not to have the song because this one that you couldn't hear the sound before, you can see the mouth moving with just the music.
Si tú supieras lo que yo sufrí por ti, teniendo que olvidarte sin saber por qué, y ahora me llamas, me quieres caer, me juras que has cambiado.
So if it picks up the music, I mean, it's not a big deal, but it works more cleanly if you just like do the lip syncing yourself. I had the students. I don't have. Let me see. I might have some of the student projects were so cute because they made jokes. Right, so
Today I will live in the moment, unless it's unpleasant, in which case I will eat a cookie.
so it's a very simple, but these kids made it.
Don't believe everything you read on the internet just because there's a picture with a quote next to it.
They keep rambling on, but it does make a good point that teachers could be using this as like, okay, so the kids build their famous person, and then they make a video of a famous speech. In this case, the kids just were fooling around. It is summer camp, so like they are not obligated to be serious. So anyway, so it's lots of fun, and you know, people respond well to it. As I'm always hoping that by introducing them to something that it's you know, super silly looking and fun, like they know they're just, they think they're just having fun. Maybe by introducing them to the physical computing and coding through that, like they'll, you know, do so much more things, in my opinion. Like I'm hoping that I inspire them to do, you know, much better. And like I can't wait to see what they come up with when they grow up. Because, you know, I didn't grow up with coding, you know, entirely. It was not my thing, but you know, combining it with art is just so much fun. I don't know if there's any more questions.
Well, thank you, Cecilia. That was awesome. Thank you for sharing your great talents and providing us with insight and other creative ways to express our robotics hobby. So that was very, very fun. Thank you. Thank you for being our featured presenter today.
You're welcome.
And with that, I think we will be officially closing the August 2022 SRS meeting. And I will be stopping the recording here in just a second. And with that, I will be opening the floor to networking, to further robotics discussions that anyone wants to stay around for. So I appreciate being your host today. I very, very much enjoyed the opportunity, and I hope everyone else enjoyed the meeting as much as I did. Thank you again.
Thank you.
And thank you again,
Thank you,
Cecilia.
Donna.
Well, thank you,
Donna.
James. Yeah, thank you.
Appreciate
Thank
it.
you, everyone.